All right, friends, it's T-Man, and I'm back with another educational video, but oh man, yeah. Okay, you probably already know this section right here because this is a carryover from this section right here. So I had posted some information from this NCBI report called Maximizing Muscle Hypertrophy, a Systematic Review of Advanced Resistance Training Techniques and Methods. You know, cluster sets, drop sets, you know, all that kind of stuff, yada, 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 whatever. Those are all great, you know, pyramiding and whatever, overloading, okay, whatever. Man, anything that would help, right? I guess the monotony, break the monotony, and try to get an adaptation. Okay, so this is a section from that section right here. I posted it above because just, you know, I don't know, man. Sometimes I was looking for stuff and I wanted to post it. I will explain this small section. Okay, so they say the use of weight releasers allow for overloading the muscles during eccentric phase releasers. They're talking about more of the, what I would call the eccentric portion. They want to overload the eccentric portion so you get negatives. This is eccentric negatives will give you a lot of damage as opposed to concentric. Concentric has nothing to do with muscle damage. Okay, so overload whatever phase. A movement due to its specific construction. Okay, the weight can be unloaded in the transition from the eccentric to the concentric phase of movement. The use of high loads during the eccentric phase of movement, listen to what they're saying. The use of high loads during the eccentric phase of movement is associated with significant exercise-induced muscle damage. Remember, eccentric is always correlated with muscle damage. Concentric, no. Eccentric, yes. But they're talking right now significant associated with significant exercise-induced muscle damage. So you're getting more muscle damage than you would usually get in that muscle. Do you understand me? Okay, and mechanical tension. So, but they all go hand in hand. The stress, the mechanical tension is with muscle damage because it's a movement. A mechanical tension means this is a mechanical tension when you take a weight and you move it up and down, okay? That's mechanical tension. Where's the stress? Well, the stress is in between. You could call it isokinetic. If the movement keeps moving and it doesn't stop, it's not isometric, it's isokinetic, that would be a lot of stress on the muscle, wouldn't it? Yeah, definitely. In other words, squats would be isokinetic, unless, of course, it's isometric if you stop with the weight. A lockout is considered isometric, even if it's a partial rep, but you're locking at the partial rep or a full lockout. But if it keeps moving, that is isokinetic. Okay, whatever. So you can overload this, okay? That's what they're talking about. So there's significant muscle damage, which definitely that's what you want, okay? Which have been associated with hypertrophic response. Muscle damage is always associated with hypertrophic response. Get it? Now, what do they mean by hypertrophic response? Well, in muscle damage, what you have is an apoptosis and a degradation in protein synthesis. You understand me? There's a degradation, but there's also a window for protein synthesis now. Get it? And a repair and a remodeling and possibly a donation of the satellite cells if you had maxed out that myonuclear domain. Look, a maxing out of a myonuclear domain means it had reached a ceiling limit during hypertrophic process, not hyperplasia process. It reached that level. In other words, the cell can only get so big. It is overseen, that cytoplasm is overseen by something called myonuclear domain size limit. Get it, man? Okay. So it reaches the ceiling limit during hypertrophic process beyond where the satellite cell can donate any extra nuclei to that domain to support any more further muscle growth. Okay? And that is an issue for a lot of people. That's why they say they reached their newbie gains and whatever, and it's hard gainer and my genetic limit and all that. You didn't. You just don't know how to get over the M&D size limit because all of you are lazy. All right. Furthermore, I'll go further into depth with this. Okay, so if there could be different types of damages. There could be minute damage, and then the body does fuck all. Then there's a repair and a remodeling damage. Okay, you get a repair and remodeling. And you can get a hypertrophic response through the repair and remodeling. Plus, it could get elongated. You can get more. In this case, it gets longer, and it also gets a bit bigger, providing protein synthesis exceeds this breakdown. You got to be in an anabolic growth state. Okay. Now, a third type of damage could be you're getting more muscle fibers, and there's a repair and a remodeling, and there's a hypertrophic response. Okay. So there you go. And you're getting a donation of these nuclei, so you can support further muscle growth. They synthesize protein. That's what they do. That's their job. Without them, you can't further that domain, okay? Anyways, all right. So furthermore, some studies have shown that performing eccentric-only contractions led to higher gains in muscle mass when compared to concentric-only actions. How does it lead to more muscle mass? Well, it really, I mean, how does it lead to more muscle mass? Well, again, protein synthesis needs to exceed this breakdown. Otherwise, it will not lead to any more muscle mass. How does it lead to more muscle mass? It just means there's more damage there. There's more windows. There's more avenues to rebuild and construct bigger and stronger. That's all. It means that there's so much a different type of architectural thing going on there. I'll explain this in the bottom. It'll explain it to you in a second. Okay, so remember, you go to the gym, you lift weights, what do you get? Well, there's a window for protein synthesis, but there's also a window for protein breakdown. See what I mean? So protein synthesis needs to exceed that breakdown in order to see that growth and that myofibrillar. Okay, whatever. Plus, if you get muscle damage, blood levels are elevated, protein synthesis is extended for that entire week during the repair and the remodeling phase. And I haven't even been in the gym right now, I think 10 days. And the previous day before I did my chest, that was 8 days. I took 8 days off, then I did my chest. And right now it's 10 days, and I may not even go in today. I probably will go in tomorrow, possibly to do my backs. And that'll be 11 days already, so whatever. Okay, why am I doing that? Because I listen to my body. I'm not like everybody else. I listen to my body, get it? It doesn't want to go to the gym, so I don't force it. Okay, so where were we? Okay, so it performs higher gains of muscle mass when compared to concentric only actions. Concentric doesn't really do a lot other than stress a cell and possibly open a window for protein synthesis, but it doesn't add additional nuclei to that domain. It can only happen when the progenitor it comes out of quiescence during muscle damage, and then it splits, divides, increases in number, okay, and donates its nuclei to that domain. Okay, and it repairs and remodels and whatever, and creates more fibers and yada, yada, yada. Nonetheless, recent literature has indicated that when the volume of training was matched with AEL and high load resistance training led to similar hypertrophic responses in groups of strength-trained athletes. Well, yeah, it could, because there's a window there, get it? It depends what type of hypertrophic response this is. Is it sarcoplasmic or is it myofibrillar growth? See, they're not really specific here. They do talk about it in this report. They do talk about sarcoplasmic training. So it's incorporated in here. You have to have read the beginning part when they opened up. They talk about it at the bottom, they talk about it at the top. So, and I'll show that to you in a minute, because some people may not understand that. Okay. So there are two types of hypertrophy training. One of the training is SSS, whatever, this sarcoplasmic training, and then there's the other one, it's myofibrillar training, whatever. The muscle damage, whatever. Okay, so the volume training, okay, similar hypertrophic responses in groups, strength-trained athletes. Furthermore, RT protocols that did not promote significant muscle, sorry, I have to open this. Furthermore, RT protocols that did not promote significant muscle damage still induced similar muscle hypertrophy. That means something is just getting bigger. Hypertrophy means something's getting bigger, that's all. But what type of hypertrophy? I know what type of hypertrophy they're talking about that exuded similar muscle hypertrophy, but not in architectural changes. That's the difference. So it induced similar muscle hypertrophy in comparison with those protocols that promoted initial muscle damage. Yes, you could say that. you could say that the RT protocols did not, okay, hold on. Furthermore, RT protocols did not promote significant muscle damage. They did not, but still induced similar muscle hypertrophy in comparison with those protocols that promoted initial muscle damage. And how did it do that? But however, here it comes. However, differences appear in muscle architecture adaptations. And why is that? Why is the architecture and adaptations different between that hypertrophy and muscle damage hypertrophy, the resistance training that they did? Because one is based on sarcoplasmic hypertrophy and the other one is based on myofibular hypertrophy. So training with the concentric only phase led to muscle whatever and the addition of sarcomeres. I can't even open this. Hold on a second. I'm going to open this, all right? So see, I'm not really into blood flow restriction. See where it says here? Okay, look way here at the top here, okay? Results concerning the time efficiency of training, the use of agonist, antagonist, upper lower body supersets, drop and cluster sets. Sarcoplasma stimulating training. Now, what do you think sarcoplasma stimulating training is? See what I mean? What do you think that is? Well, I'll tell you what it is. I'll explain what that is in a minute. All right? It's based on ATP. It's an energy source, okay? It's fluid in the muscle, and that makes the muscle hypertrophy, but it doesn't add an addition of sarcomeres or muscles. It doesn't add muscles. It's not based on contractile proteins, dude. So yeah. Hold on a second. Let me try to find this one section. I don't know if I can find it now. Inclusion? I think it was under inclusion. Training considerations. Yeah, I don't remember. Attenuated here. There's attenuated eccentric loads. Okay, here it was. That was that section where I was reading to you. Remember, furthermore, RT protocols right there. However, the differences appear in muscle architecture. Let me scroll this up a bit. The differences appear in muscle architecture adaptations. Training with the concentric only phase led to muscle growth mainly by the addition of what? Okay, with the concentric only, in addition of sarcomeres. That's interesting. Wow. Training with concentric only phase led to muscle growth mainly by the addition of sarcomeres in parallel. Well, that would be a type of stretch, wouldn't it? That's interesting. I didn't know that. See, the things you learn. I mean, I did read this. Increased pennation angle with little change in fascicle length, while training with eccentric only contractions led by the addition of sarcomere in series. Well, then it can't be concentric can't grow addition. It can't lead to addition of sarcomeres. That's crazy. This has to be eccentric. Training with the concentric only phase led to muscle growth mainly by the addition of sarcomeres. But they're telling you here that it was led by eccentric only contractions led by addition of sarcomeres in series. Increased fascicle length and small increases in the pennation angle. Yeah, maybe this is just confusing here, man. I don't know. Maybe I'm misreading this, but I don't know of any eccentric exercise that could lead to a stretch. The sarcomeres are that stretchy material inside the muscle. If there's more of the stretchy material, if it increases, the sarcomeres increase in number, that means you have more stretchy material in there. So it can only be through eccentric. Maybe I'm just misreading. I'm not understanding that. I don't know. Furthermore, due to greater mechanical tension, it could be provided an additional hypertrophic stimulus, although it must be noted that the main disadvantage of this technique is necessary of weight releasers on the presence of experienced spotters during training. I talked about this previously in the last video. Moreover, AAL requires the eccentric load to reload after every repetition. Thus, it's possible that the inner repetition rest may excessively extend the time of particular repetitions and the whole training session. Yeah, it goes on forever. So that other stuff that I was, so different architectural changes is what happens from this so-called sarcomere stuff. Just a second here. So what is sarcoplasmic stimulating training? What is it? Sarcoplasmic stimulating training, SS, is the acronym for sarcoplasma stimulating training, a high-intensity work method for increasing sarcoplasmic hypertrophy. A variation of the SS method refers to performing 8 sets to 70-80% 1 RM with program rest intervals between yada 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 yada. But what is sarcoplasmic hypertrophy? What is that? Well, people get it in this type of people that are trained, usually people that are trained get sarcoplasmic hypertrophy because they're not shooting for an adaptation in muscle damage. And not everybody's getting damaged. I'm not saying people aren't getting damaged out there. Some people get some damage, but they're not eating enough. Okay, this is the longer version. Wait, I need the shorter version here, PubMed. Okay, there you go. So muscle fiber hypertrophy in response to 6 weeks of high volume resistance training. They talked about that. They talked about high volume in there. Get it? That was the change in architectural changes. The architectural changes are what? One is based on sarcoplasmic hypertrophy. It says here, volume resistance training in trained young men is largely attributed to what? Sarcoplasmic hypertrophy. So yes, man, there is such a thing called sarcoplasmic hypertrophy, and there is such a thing called myofibrillar hypertrophy. Get it? There's more than one type of hypertrophy. Okay, dude? So yeah, if you want, you can read this yourself. It's based on glycogen. They even tell you here it's glycogen loading in the muscles. And while the muscle glycogen concentrations remained unaltered, citric phase, 24%, suggesting mitochondrial volume decrease, They talk about a whole bunch of shit here. But basically, it is sarcoplasmic protein. This isn't contractile proteins. This is sarcoplasmic protein, like it says there. Mitochondria and glycogen concentrations were altered in individuals that exhibited mean skeletal muscle fiber cross-sectional area. So yeah, man. Okay, so there is such a thing. Okay, because people keep arguing. There is such a thing. It exists. It definitely exists. It's out there. And there is such a thing as hyperplasia. It exists. It's out there, dude. It exists. It's out there. This section, I put this section in here so you could probably read it. You could read this. That was the whole part here for sarcoplasmic training. It was actually, I posted it here again. It's up there, whatever. There's another section you could go way down here. Let me go there really quick. Sorry, there's so many videos to go through here. Sorry about that. Fortunately, I just post way too much stuff, man. Okay, yeah, not the role of touring. Not this either. Hold on. We're almost there. Somewhere over here. Here we are. The different modes of hypertrophy in skeletal muscle. The different modes. So in this section here, they talk about hypertrophy is defined as the increase in the ratio of cytoplasm to nucleus. See? The ratio to cytoplasm to nucleus, whereas hyperplasia is defined as the nuclear division. What's a division? Dividing. Cells are dividing. Oh, that's hyperplasia. See, nuclear division and an increase in the number of cells. And if there's an increase in the number of cells, that's called hyperplasia. So that's why they're telling you where hyperplasia is defined as the nuclear division. See, where Jason Blaha and all the rest of these people on the internet are telling you that hyperplasia doesn't exist. Well, it does exist. And what is it? Hyperplasia is defined as the nuclear division. What is that? Myonuclear domain size limit had reached the ceiling limit during hypertrophic process, beyond where the extranuclei donated by satellite cell to support further muscle growth. Get it, man? Look, I'll even read this to you, okay? Here, I'll bring it up for you. Just in case you don't understand this. Maybe people just, they don't get it, dude. Okay, it's called myonuclear domain size. See, this is myonuclear, right? Okay. So let's go back here. What do they say? What? Oh shit, I lost that, damn it. I hate when that happens. Okay, so what did, this is from that section again, modes of hypertrophy. So what did they say here? They say that whereas hyperplasia is defined as the nuclear division and an increase in the number of cells, right? That's what it is, right? Okay. Myonuclear domain size limit. MND size has a ceiling limit during hypertrophic process beyond which extra myonuclei are donated by satellite cell to support further muscle growth. How does the satellite cell donate it? Through muscle damage. That's how. It is activated through muscle damage, and that's how it does it. Okay, dude? That's how it does it. I'm sorry. Shit, man. This thing went off again. Fuck, it does this all the time. I have to go back there again. Sorry about that. That really sucks. You know, you're trying to make a point, and this is so like interrupting. I don't know why it does that. The problem is I have so many videos here I can't get to the information because they're sequenced. All right, so let me go back here, different modes again. So now you understand that it's about nuclear division. What is nuclear division? Myonuclei. Hyperplasia defined as nuclear division. Nuclear division, myonuclei, and an increase in the number of cells. Okay? In contrast, hypertrophy of skeletal muscle is thought to involve the increase in the number of nuclei as well as the increase in cytoplasmic volume. Hypertrophy of skeletal muscle therefore incorporates part of the definition for what? Hyperplasia. So it does exist. Okay, man? It doesn't just exist in fucking birds that they did a test on with a locket. Okay, an increase in the number of nuclei. As further complications, the additional nuclei may come from internal nuclear division or fused satellite cells and their donated nuclei, thus evidence of DNA synthesis and hallmark of what? Hyperplasia. Okay, dude? So are we clear with that, man? I hope so. Here's another one. Fusion and beyond satellite cell contributions to loading-induced skeletal muscle adaptations. So you can read this for yourself. The fusion of satellite cells driven by the cell autonomous and or extrinsic factors contributes new nuclei to muscle fibers associated with what? Load-in-induced hypertrophy and may support focal membrane damage. What does this mean, load-in-induced hypertrophy? They're talking about protein synthesis needs to exceed that breakdown. The contractile proteins, the cytoplasm of that cell, can only get so big. It's overseen by the MND size limit. So what does it need to do? You need to reach that, you need to force that domain and then damage muscles. So focus more on food, be in an anabolic growth state, push that domain, and then it'll donate its nuclei to support further muscle growth. It won't support it on a bagel and cheeseburger McDonald's dinner, okay? Or whatever, lunch. Bro, it ain't gonna work. If you ain't in an anabolic growth state and you're not pushing that domain beyond that hypertrophic limit, then it will not donate its nuclei regardless if you damage muscle fibers. That's why I'm very careful in my exercise regime. I never go to the gym to lift weights if I can't be in an anabolic growth state. There's just no point for me to lift there. I'm going to waste my time and do what? You're not going to get anything. So yeah, that's what they're trying to explain to you. Satellite cells supports skeletal muscle fiber adaptations to loading in numerous ways. In numerous ways, bro. Get it? The fusion of satellite cells driven by cell autonomous and or extrinsic factors contributes new myonuclei to muscle fibers associated with what? Load-induced hypertrophy. What does that mean? What does that mean exactly? See what I mean? What does that mean to you? Still has to reach a domain limit. And may support focal membrane damage repair and long-term myonuclear transcription output. Recent studies have also revealed that satellite cells can communicate within their niche to mediate muscle remodeling, response, and resistance exercise. Regulating the activity of numerous cell types throughout various mechanisms such as I don't know what the fuck they're talking about here. Secretory signaling and cell-cell contact, whatever. Muscular adaptations, resistance, and resistance, whatever, activities, and so forth and so on. They're going to go on forever there. I'm not going to read it all. Cell types of various, okay, it's over here actually. Signaling, cell-cell contact, muscular adaptation, resistance to initial. Sustained for periods of time, the absence of satellite cells, but satellite cell what the fuck is this? Fuck, I can't even read this. It's like fucking cut off here. Participation is ultimately required to achieve full adaptive potential. It is, yeah, whatever. Okay, be it growth, function, or perspective coordination. But it doesn't grow without any material called food, okay? If you don't eat food, it's never going to grow, okay? So there you go. While significant progress has been in understanding the roles of satellite cells in adult skeletal muscle over the few years, decades, many conclusions have been troubled, whatever, regeneration studies, okay, whatever. I don't know if I posted any more. Did I post any more stuff here? Many conclusions have been extrapolated from regeneration studies, highlights, okay, yeah. Satellite cell behavior and contributions to adaptations. It usually does give it to adaptations. So you know what? Food is an adaptation too. There's an adaptation if muscle grows through protein synthesis, exceeds this breakdown. That's an adaptation. You could call eating an adaptation. If you don't eat, then one adaptation cannot override the other adaptation. In other words, without one adaptation, the other one won't work. If you don't eat, it's not going to work. So whatever you do there, forget it. The adaptation outside of regeneration in adult muscle, as well as the roles of satellite cell beyond fusion and myonuclear accretion, which is gaining broader recognition. Yes, it's not anything new, man. It's old stuff already. This is all fucking old news, bro. But anyways, I hope that helped, man. I can't go into further detail. I post a lot of stuff in here. It's way down at the bottom now. It's all lost already. So you got to scroll all the way down there. I'm not going to scroll all the way down to the bottom. But you get the gist of what I'm trying to explain to you here. You know what this is. I'll see you in the next one, friends. I got to go. Tell me what you think about that. Like, subscribe, support the channel. I'm going to go. I hope that helped. I don't know. Maybe that helped. That didn't help. I have done sequences on some of these reports previously. I talked about them. There's some videos way backed up and down at the bottom down there somewhere. If you want, check it out. And it does. There is such a thing as sarcoplasmic hypertrophy, okay? And one can exceed the other. One can exceed the other. You understand me? In other words, myofibrillar growth can exceed sarcoplasmic, and sarcoplasmic can exceed myofibrillar growth. But sarcoplasmic hypertrophy training, sarcoplasma training is not regulated by follistatin, myostatin, or the satellite cell, or the myonuclear domain size limit, which is satellite cell, okay? It's not regulated by that, okay? It's not controlled by that. It's controlled by how much glycogen you're loading in the muscles. There has to be a window there for glycogen synthesis, not protein synthesis, but glycogen synthesis. And since the majority of people, you people going in the gym, getting the pump, chasing the pump and getting this pump and doing this weird pump stuff, pump work, whatever, that's basically sarcoplasmic hypertrophy. That's what it is, man. You're drawing, for every gram of glycogen, 3 grams of water drawn between skin and muscle into the muscle, creating these phony, fake muscles. It's artificial muscle growth, okay? I'll see you in the next one, man. Like I said, tell me what you think about that. Like, subscribe, support the channel. You get the gist of it, man. I'll see you in the next one. Ciao. If you have any questions, comment down below. I'll try to answer them, and maybe I'll do some other stuff on this again. I don't know. It gets tiring to do this stuff, but I'll do it anyway. But it gets tiring after a while doing it over and over again. But okay, there are some new stuff. I'm always finding new reports. Some I've read before. I just find them again, and then I brought them back because I used to have them on my old channel, and I keep trying to bring them back now. But okay, I'll see you in the next one. Ciao, friends.